Hello, you know what time it is. It's time to review some algebra, starting with number 2. So we are going to define or describe what's happening with this function with some mathy things that tell us a little bit about what this function is doing. Whoop. So first off, um, there are some key things that you need to know, like the minimums and maximums, the x-intercepts, and the domain, to name a few. And those really guide everything else. The one thing that's kind of random almost is the y-intercept. That's known as like the starting point generally. When x is 0, is if this is something that depends on time, then the y-intercept would be the starting points wherever it begins. And so this one begins when x is 0, y is -5. So there's the first point, and we will not say anything else about it. Okay, domain. Domain represents what parts of the x-axis do you expect to see the function, basically. What is the lowest x value that you might have? What is the highest x value that you will have? And are there any gaps in between? So generally speaking, there could be infinite negative numbers that this function goes to. And our function is going to continue to go left, and there's nothing that's going to stop it. There's no barriers there. And it's also going to go to the right forever. So from -infinity to +infinity, that's the domain. And for polynomials, that's always the domain. So linear functions like number 1, quadratic functions like number 2, always going to have all real numbers as the domain, from negative to +infinity. And that means, so spoiler alert, that means that when we do intervals, positive, negative, increasing, decreasing, you're going to start with -infinity, and you're going to end with negative or with +infinity somewhere as we describe those x values. So keep that in mind when we move on to intervals. All right. One point of interest is a maximum or minimum point. And on this function, if you have a maximum, that would be the highest, and we do, -3, 4. So that's the location of the maximum. And this would be classified as an absolute maximum rather than relative, because it absolutely never goes above that point. Not even later on do you see the function move above that point. As far as minimums go, minimum would be what's the lowest y value that this function achieves, or where's the lowest point. And it doesn't have a point. If you keep looking, you'll keep finding lower points. No matter how far you go, there's always a place you could go further in the negative direction. Okay, and so those maximum that maximum point allows us to do intervals increasing and decreasing, because a maximum is defined as the place where a function stops increasing and starts decreasing, and it happens at that moment. When is that? When x is -3. Notice I said when. It's the x value that we're trying to describe. Increasing refers to the y values. The y values are getting bigger. Decreasing, that's y values. The y values are getting smaller and getting lower. So we are just saying what x values that happens, for what x values that happens. Your first interval happens from -infinity to -3. And what's happening during that interval? It's increasing. So -infinity to -3, it's increasing. Well, if it stops increasing at -3, what does it start doing? It starts decreasing. So at -3, it's going to decrease. And does it ever stop decreasing? No. And so that means from -3 to +infinity, that's our second interval. And then we're done with that part. So I'm going to erase everything that had to do with increasing and decreasing. We're done with that for now. We will also use the maximum point to define the range. So just like domain is lowest to highest x values, the range is lowest to highest y values. So is there a lowest place that this function gets? Is there a minimum? No. So it goes down to -infinity. I don't know why I'm being so passionate about this today, but And then is there a maximum? Absolutely there is, but we don't care about when it is at this moment. We care about where it is. It goes up to +4. That's the highest that the function gets. So that we're defining the y values with the range. We're defining the x values with the domain. So this function will have every x value represented, and it will have -infinity to 4 represented, but you're never going to get a 5 to come out of this function. And that might be interesting to you. If you need a 5, then you're like, well, then I'm going to have to look somewhere else. Okay, so what do we have left? We've got x-intercepts, and then we've got intervals positive, intervals negative, and those are connected. So the x-intercepts, that's where the function crosses the x-axis. That happens at -5, or when x is -5, and when x is -1. So let's write those points. -5, 0, that is an x-intercept. Anytime the y value is 0, it's crossing the x-axis. That's the definition. And -1, 0 is the other x-intercept. We can see those. We also know how to find those on the calculator, but we don't have the function. We just have the graph, and that's all we need for that. Okay, so then what are the intervals positive and what are the intervals negative? Let's see. So positive, let's use red for positive. Anytime the function is above the x-axis, it's up here, that is when the function is positive. And so you see that that happens. Let's do something crazy. Let's use the white color. That's this portion of the graph right here. It is in the positive region, -5, -1. And then negative is anytime it's below that line. I don't know why this is harder to shade down here, but so anytime it's down here, that's negative. And you see that there's two portions when that happens. So we have to define all of those moments when those things happen. So the first interval is from -infinity until the first x-intercept, which is -5. So from -infinity to -5, what's happening? That's this part of the line right here. It's in the negative region. That means the y values are negative. So interval negative, -infinity to -5. Well, if it stops being negative at that point, where does it, or what does it start doing? It starts being positive. So from -5 to -1, this function is positive, -5 to -1. And if it stops being positive at that point, it starts being negative from -1. And does it ever stop being negative? No. This thing never turns back around and goes back up. Doesn't happen. Stays negative forever. Notice it's positive infinity, not negative, because this is not a question of where is it going? Yeah, it's going down in the negative direction, but that's negative. We would be explaining the same thing twice. We want to know when, and basically the answer is forever as you go to the right. So that's intervals positive and negative, and I want to make sure you see this. So -infinity to positive infinity. We have to account for the whole domain. Same thing for these intervals, -infinity, positive infinity. The places where it changes, -5 and -1. These are the x-intercepts. For the intervals increasing and decreasing, this is -3 and -3. That's the maximum point, or the x value of the maximum point. All right, one last thing, and then we'll be done with this one. In behavior, how do the ends behave? The ends, we're talking about this one and this one. And it's just like, if you're looking at this function, you decide, hey, I'm going to go in the left direction. What's going to happen? Well, you see that you would start moving in the downward direction as well. So the left direction, what's over there? -infinity. So the x values are going towards -infinity. Well, what's happening to the y values at that point? They're going down forever, which is the negative direction, and they don't ever stop. On the right side, the values, what's going on the right side? Hey, that's where positive infinity is. So if you move to the right on this function, the values will get bigger and bigger and bigger forever. And what happens to the y values during that time? They start to go in the negative direction, and they get more and more negative forever. So that's the end behavior. The x values on the end behavior portion, those are always going to be the same, just like this, left side negative infinity, right side infinity. And then on the y side, with quadratics, they either point up on both ends or down on both ends. This one points down on both ends, that's negative forever. If they both pointed up, it would be positive for both of those y values. So that's number 2. We will pick it up in another video with the next one.